Welcome back, everybody. My name is Andres Hernandez, and today I'll be starting a new series here on my channel called The Top 50 Most Concerning Chemicals. I will be starting at number 27 with Aloclor 1248, which sounds like a good password in my opinion. So Aloclor 1248 is considered a polychlorinated biphenyl, a PCB mixture, with a chemical structure of 6 carbons, 12 hydrogens, and 4 chlorines. As you can see here, it is made up of 2 carbon rings with 2 chlorines attached on each side. So, moving on, let's discuss its possible toxicokinetics and dynamics, which is just a fancy way of saying how will this chemical react in my body at unholy amounts. So it has been documented that Aloclor 1248 increases expression of the Bax protein and decreases expression of the caspase 3 protein, where both of these proteins are involved in cell death in the mitochondrial outer membrane. In other words, the increase in the Bax protein will facilitate an even greater amount of cell deaths, while a decrease in the caspase 3 protein will limit their role in controlling cell deaths. Next, we discuss its pharmacology and biochemistry, which roughly translate to how will this chemical react in my body in controlled amount. To demonstrate this, scientists administered an oral dose to monkeys, where Aloclor 1248 was absorbed from the gastrointestinal tract, basically the passageway of one end to another, if you catch my drift. It was shown that by the 14th day, 5.6% of the original dose had been eliminated in the urine and feces. Unfortunately, from the reports that I read, it was not clearly mentioned if the monkeys suffered physical pain or harm from this experiment. Now let's get down to what everyone has on their mind. What are the U.S. regulations and exposure levels? So in the U.S., it is classified as a health hazard and environmental hazard. Under the National Fire Protection Agency, it received a health rating of 2. A level 2 rating means that under continued exposure, it can cause incapacitation or residual injury. It also received a fire rating of 1, meaning the chemical would have to be preheated in order to be flammable. Under these conditions, it is also recommended that a 10-hour limit of exposure be set, and also recommended to wear full protective clothing along with a positive pressure breathing apparatus. Now you might be asking yourselves, do we even use this chemical? And the answer is yes. Well, we used to. See, the U.S. produced this chemical commercially up until October of 1977, when production stopped. It was formerly used in hydraulic fluids, vacuum pumps, rubber plasticizers, synthetic resins, and adhesives, mostly just industrial use. One catastrophic event involving PCBs took place in 1968 in Western Japan. It was a mass food poisoning incident involving more than 1,800 people, coined the Yusho disease, translated from oil disease in Japanese. The main cause was the ingestion of rice bran oil that had been contaminated with PCBs and polychlorinated dibenzofurans. It caused a range of effects including premature birth, infant mortality, along with acute symptoms such as chloracne. Well, that concludes this video.